At complex numbers. Complex numbers have the following, or the type of numbers that we've looked at so far have been real numbers. Real numbers have the form A, just any of the numbers that we've talked about. Complex numbers, on the other hand, extend this beyond just the real numbers. It does often contain a real number portion to it, but it's also going to contain an imaginary portion. Okay, so this portion right here is the imaginary number. And again, this would be the real number portion of it. Okay, and the imaginary portion is just the portion that contains I. And I, have any of you been exposed to that? Did you guys talk about that at all in algebra, do you recall? I represents the square root of -1. Okay, so in the work that we've done so far, if you came up with an answer of -√4, it's impossible to represent this in the real number system. Okay, so your answer would be not possible, no solution. Okay, but now what we're going to start to see is that we can express this in a different system, the complex number system, because the square root of -1 can be replaced with an I, and you can still work and solve through your problem in that form. Okay, so if you think of this as being square root of 4 times the square root of -1, what you can then do is simplify. Square root of 4 simplifies to a 2, and the square root of -1 can be reduced and rewritten as an I. So we can now express negative square roots in terms of a number, an imaginary, using that imaginary unit I. Okay, now if we were to build this back up, we would see how it's derived. So if we were to square both sides of this equation, we would see that I squared itself is equivalent to -1. Again, it's an imaginary number. It doesn't exist in the real number system, but it's the value that you could square to get a -1.